Welcome to a lesson with Dr. Powell. Let's take a look at another piecewise defined function. Suppose we have f of x is equal to, let's do 3 plus the absolute value of x minus 1. And then let's do 2, and let's do x plus, actually, let's do x minus 5 quantity squared plus 1. All right. Suppose we got this when x is less than 0. This when x is between 4, let's see, so bigger than 0, so 0, and then up to 4. And suppose it's this when x is greater than or equal to 4. Okay, so that's our graph. That's our piecewise function. Let's look at what the graph of this thing would look like. Okay, remember these are like y equals, y equals, y equals. And we can think of transformations a little bit as we graph this piecewise function. Okay, so for starters, 0, maybe we could split up the domain of these different parts. I mean, 0 and 4, and so we have one of these functions in here. It's this one is right in the middle. This one is over here to the left, and then this one right here is over here. Okay, so how is this going to work? Okay, so if x is less than 0, then we're looking at this. And what does this look like, first of all? Well, x transformations looks like we have a absolute value and we move 1 to the right, and then we move 3 up. So kind of absolute value is a v, move 1 to the right, and then move 3 up. So, and so really it's going to be graphed. Okay, so we have so suppose we moved up 1 and move 3 up. And so it looks something like this. And then it goes up with the slope of just -1 still going up that way. Okay, and we only want a part of the graph that's less than 0. In fact, if we just plugged in x is 0, we notice we have 3 plus absolute value of -1. So 3 plus 1, which is just 4. So we should be at 4 right there. And we don't want the part of the graph that goes up like this. And we don't even want this part. And the reason why is because the filter here tells us this part has to be where less is less than 0. So maybe put an open circle right there. Okay, so that's that part of the graph. Now, the next one, from 0 to 4, we have 2 going on here. And let's see, so 2, and so from here, and it's equal to at value 0, and it goes all the way to 4, not including it. Okay, and then the next piece, okay, is think of a transformation of a parabola y equals x squared. We've shifted 5 to the right. In fact, the vertex is going to be at 5, and then it's shifted up to 1. So that's the new vertex. And at 4, let's see what it is at 4. In fact, if we plug in 4, you'll notice you'll get 2. 4 minus 5 is -1. Squared is +1 plus 1. Be 2. Hey, that's that value there. It's kind of handy. It just kind of comes up there. But notice how it's greater than or equal to, and so it's going to it actually fills in the hole. So this part and this part actually match up right there at that question point to actually fill in the hole right there. It's kind of nice, handy. And then the graph just symmetrically kind of comes up like this. So what we just did is we graphed this piecewise function. Make sure it passes the vertical line test, and it does everywhere. So we're set to go that way. Now let's just practice plugging in a value. Okay, let's suppose we plugged in f of 5. Where would we go? Well, 5 goes into the filter, and the only place it can go through is this one. X is greater than or equal to 4 because 5 is greater than or equal to 4. So it comes in here. You put 5 in here. 5 minus 5 is 0 squared. Plus 1, you just get 1. So there's an example of evaluating the function. All right. Thanks for watching.